In this video, we'll see how to conduct a hypothesis test for an association between two quantitative variables. This is equivalent to testing whether the line of best fit in the population has a slope different from 0. Let's investigate this research question. Do students who spend more time on non-academic activities, like socializing or jobs, have lower GPAs? We'll study this using data from the University of Minnesota, available on our textbook website. Our null hypothesis will be that in this population, students at the University of Minnesota, there is no association between the number of hours students spend on non-academic activities and student GPA. So, just like for other types of tests of association, such as a 2-proportion z-test or a 2-sample t-test, our null hypothesis is that there's no association between the variables. In symbols, we would write this as the null hypothesis is that beta equals 0, where beta is the slope of the line of best fit if we could make a scatter plot of all the people in the population. Our alternative hypothesis will be that in this population, there is a negative association between the number of hours students spend on non-academic activities and student GPA. In other words, when people spend more hours on non-academic activities, they tend to have a lower GPA. In symbols, this would be beta is less than 0. So the slope of the line of best fit in the population is negative. To simulate results where the null hypothesis is true, we'll imagine having one card per observational unit. In this case, one card per student. And each card has written on it that student's number of hours that they spend on non-academic activities and that student's GPA. So they're values of both the explanatory and the response variables. Then we'll imagine tearing each card in half so that the GPAs are no longer connected to the hours. And we'll shuffle the top and bottom halves and reassort them. So we now have a bunch of simulated people, each with a number of hours and with a GPA, but we've broken any relationship that there might have been between their number of hours and their GPA that we had on the original cards, because we literally broke the cards apart and reshuffled them. We'll compute the slope of the regression line for the shuffled data. So the slope of the line of best fit will be our test statistic. And repeat this many times, say 1,000.
Here's the GPA dataset on our textbook website. I'm going to press Control-A to highlight all and Control-C to copy, and then I'll switch over to the correlation and regression applet. We'll clear out the existing data in the applet and press Control-V to paste in our new data. So clicking Use Data will now show each row, which represents one student, has now become one dot in our scatter plot. So the coordinate on the x-axis, the horizontal axis, is that student's number of hours spent on non-academic activities, and the coordinate on the vertical axis, the y-axis, is showing that student's GPA. So just looking at this scatter plot, it looks pretty noisy. It doesn't look like there's a strong relationship between GPA and the number of hours. So let's find out if the relationship is strong enough when combined with the sample size to give us strong evidence of a relationship in the population, not just this sample. So we'll start by scrolling down and clicking Show Regression Line. So here we can see our line of best fit in red here, and it does have a negative slope. So these two variables are negatively related within this sample. And our slope of the line of best fit in this sample is negative 0.0059. So that will be our test statistic that we'll want to find the probability of being at least as extreme as that number. All right, so now let's generate our simulations by clicking Show Shuffle Options. And I'm going to choose my statistic to be the slope of the line of best fit. And let's start by showing the data when we shuffle. So let's do a single shuffle. And here we can see our shuffled data. So this contains all the same values of hours and GPA as were in the original data, but the numbers of hours maybe now are lined up with different values of the GPA. So we've shuffled the rows here. If we click on Plot, we can see those values plotted in a scatter plot. And in red, we have our original slope, our original line of best fit from our original sample. And in blue, we have the line of best fit for the current simulation. If we scroll over to the right, we see in blue, we have the slope of the line of best fit from this shuffle. So now let's go ahead and do 999 more shuffles. So now we can see our rightmost graph has the null distribution of the slopes of the lines of best fit from our shuffled samples. And you can see that it has a mean of 0, which makes sense because our null hypothesis said that the slope in the population was 0. Here in gray, we have all of the lines of best fit that we got from different shuffles. So you can see that the red line from our original sample is sort of off to the edge of that region, showing us that it's somewhat unusual, but not extremely unusual, if the null hypothesis were true. To get the p-value, we want to count the shuffles that are at least as extreme as what we found in our data, which was negative 0.0059. And for what counts as at least as extreme, we want to look at our alternative hypothesis. For this study, our alternative hypothesis was that there was a negative association between GPA and hours on non-academic activities, or that the slope was negative. So we want to count shuffles that are less than or equal to the slope in our sample. So here we find that there were 41 out of 1,000 simulations that were at least as extreme as what we got in our actual data. So our p-value is 0.041.
So here, because our p-value was less than 0.05, our conclusion can be that there is strong evidence of a negative association between the number of hours students spend on non-academic activities and their GPA in this population.